Imagine walking into a doctor's office. You're not feeling great, headache, fever, sore throat. The doctor takes a quick look and says, it's probably the flu. But what if there was another way? What if an AI system trained on thousands, maybe millions of cases could assist the doctor in making a faster, more accurate diagnosis? Would you trust it? That's exactly what we're exploring today. How AI is revolutionizing medical diagnosis using a technique called Bernoulli Naive Bayes. It sounds complicated, but by the end of this video, you'll see how it works in real-world healthcare, how hospitals are using it right now, and why it could save lives. Stick around to the end because we're not just talking theory. We'll break it down with real examples, show you how it works in Python, and even discuss what's next for AI in medicine. If you're in tech, healthcare, or just curious about how AI will shape the future, this is for you. Before we dive in, make sure you subscribe to the channel and hit that notification bell. We bring real-world AI insights, explained simply, so you don't just learn, but actually understand how it works. Now, let's get started. Imagine this. You wake up feeling terrible. Your head is pounding, your throat is sore, and you've got chills running down your spine. It's probably just the flu, right? But what if it's something more serious? What if those symptoms are actually the first signs of something rare, something that even your doctor might overlook? Now, let's zoom out. Picture a crowded hospital on a Monday morning. The waiting room is packed. The nurses are scrambling. The doctors are moving at lightning speed, seeing patient after patient, making snap decisions based on symptoms they've seen 1,000 times before. But here's the thing. Medicine isn't always obvious. Symptoms can be deceiving. The common cold and pneumonia can start off the same way. A migraine and a brain tumor, sometimes even the symptoms overlap. Even the best doctors rely on experience, intuition, and probability, but they're still human. They're juggling hundreds of cases, working long shifts, and facing time pressure that forces them to make quick calls. And while experience is powerful, it has limits. What if there was a way to check every patient's symptoms against millions of past cases? What if instead of a guess, doctors had a second opinion that was purely mathematical, based on hard data, and completely unbiased? That's where AI steps in. The AI model we're talking about today, Bernoulli Naive Bayes, doesn't rely on intuition. It calculates. It sees every symptom as a binary decision. Fever? Yes or no. Cough? Yes or no. Chest pain? Yes or no. And in seconds, it can predict the probability of different diseases, just like a doctor making an educated guess, but powered by thousands, even millions of past cases. Sounds incredible, right? But here's the real question. Can an AI actually diagnose better than a doctor? Can we trust it? Imagine you're in a casino, standing in front of a game where the rules are simple. You press a button, and there are only two possible outcomes: win or lose. No in-betweens, no partial wins, just one or the other. You play the game enough times and patterns start to emerge. Maybe you win 30% of the time, maybe 70%, but over time you get a sense of the probability behind the game. Now, shift that thought into the world of medicine. A patient walks into a doctor's office coughing and shivering. The doctor starts mentally checking off symptoms. Fever, yes. Cough, yes. Shortness of breath, no. Right there, they're subconsciously playing the same probability game as you were in the casino. Based on years of experience, they've seen this pattern before. Maybe 80% of patients with these symptoms have the flu, 15% have pneumonia, and 5% have something else. The diagnosis isn't magic. It's pattern recognition built from experience. But what if you could replace that human experience with raw data? What if, instead of relying on memory and intuition, you had a system that could instantly calculate the probability of every possible disease based on thousands, even millions of past cases? That's where the Bernoulli distribution comes in. At its core, the Bernoulli distribution is the mathematical backbone behind these types of yes or no, black and white decisions. Every symptom, every test result, every patient record can be broken down into one of two possibilities: present or absent, positive or negative, 1 or 0. Fever, yes or no. Cough, yes or no. Does the patient have the disease? Yes or no. This is the exact logic that powers Bernoulli Naive Bayes, the machine learning model that's transforming medical diagnosis. It doesn't try to analyze symptoms the way a doctor would. It doesn't deal in shades of uncertainty. It simply takes raw data and calculates probabilities. If historically 90% of flu patients have had a fever, then when a new patient walks in with a fever, that number gets factored into the equation. If only 20% of pneumonia patients get chills, then that factor gets adjusted accordingly. Every symptom adds weight to the decision, pushing the probability in one direction or another, until the AI delivers an answer. Based on the data, the patient most likely has this condition. What makes this so powerful is its simplicity. Unlike deep learning models that require enormous datasets and complex computations, the Bernoulli distribution thrives in situations where data is limited but structured. That's why it works so well in medicine, where diagnoses often boil down to a series of binary tests. It's why this method is already being used in hospitals to assist with disease detection, helping doctors make faster, more accurate decisions. But here's the real question. Is this binary approach enough? Can an AI that sees everything in black and white truly understand the messy, complex world of human health? That's what we'll explore in the next slide. Imagine stepping into the shoes of a doctor in a fast-paced hospital. Patients are coming in one after another, each with a unique mix of symptoms. Some have a cough, some have a fever, some feel exhausted but don't have any visible signs of illness. The doctor has to process all this information in seconds, deciding who gets treatment, who needs more tests, and who just needs rest at home. But what if, instead of intuition and experience, the doctor had something else? A tool that could instantly scan every past case in medical history and tell them exactly what the patient is likely suffering from? That's where binary variables come into play. To a human, a diagnosis is a complex, nuanced process. To an AI, it's a structured data problem, where symptoms are nothing more than yes or no questions. Instead of trying to interpret feelings, behaviors, or subtle variations, AI reduces everything to pure data points. Think of it like a medical checklist. Fever, yes or no. Cough, yes or no. Shortness of breath, yes or no. The AI doesn't ask how bad the fever is, how long the cough has lasted, or whether the patient looks particularly unwell. It just sees a series of binary decisions. It's like flipping switches, on or off, 1 or 0. The more switches flipped in a particular pattern, the stronger the probability of a certain diagnosis. This is exactly how Bernoulli Naive Bayes operates. It doesn't get caught up in the complexities of human symptoms. It doesn't need context, emotions, or second guesses. It looks at a massive data set of past patients and sees patterns in the numbers. If 85% of patients with flu had a fever, that data gets factored into the calculation. If 70% of pneumonia cases had a cough, but only 20% of flu cases did, the AI weighs that information accordingly. And the more data it has, the smarter it becomes. It refines its probabilities with every new patient, learning to detect even the subtlest correlations that doctors might overlook. In a way, it's like having the combined knowledge of every doctor who has ever lived, stored in a system that never forgets, never gets tired, and never relies on gut instinct. But there's a challenge. While binary variables make AI incredibly efficient at spotting patterns, they also simplify things too much. Humans aren't simple yes or no cases. Symptoms can vary in intensity, overlap with multiple diseases, or change over time. A patient might have a mild fever and a cough today, but develop shortness of breath tomorrow. AI doesn't always handle that well because it doesn't understand context. It only sees snapshots of data frozen in time. So the real question is, can an AI that reduces everything to ones and zeros really compete with human intuition, or does it need something more? That's what we'll explore next. Imagine